When you are looking for domain and range in an algebraic sense, you're looking for things that might give you a restriction, okay? So like a quadratic has restrictions not with our x values, but with our y values because we know how quadratics behave. So we're looking for restrictions. The first restriction that we want to look at is a rational function. Rational functions are fraction functions. It means that we might have x in the denominator. For instance, f of x equals 1 over 3x minus 5. We know that a restriction with a fraction is that you cannot have a 0 in the denominator. So that's going to restrict what we plug in for x. If we plugged in something that would give us 0 in the denominator, it wouldn't work. It would be undefined. So we have to figure out what is the value that would give us 0. So we would say, hey, well, I know that my restriction here for my domain is that 3x minus 5 cannot be equal to 0. The entire denominator cannot be equal to 0. Then, if I solve for x, 3x cannot equal 5, x cannot equal 5/3. You then find out what is my restriction on my domain. With fraction functions or rational functions, that is your only restriction. Besides that, everything else works totally fine. You could have negative numbers in the denominator, you could have positive numbers in the denominator. There's no other restrictions besides just at 0. Which means when we're finding our domain, it's the set of all x values such that x cannot equal 5/3. And that's all you have to say, because that implies, well, everything else works besides 5/3. And so that's all you have to say with rational functions. Our other restriction that we need to watch out for is a even radical function. Radical, we know, is like a square root. So for instance, f of x equals the square root of 3x minus 5. And we know that inside the square roots, if we're talking about a graph, a visual representation, we're talking about the real world and the real numbers, we know that a graph of a square root, or that a square root can't have a negative number on the inside. That is the restriction with even radicals. It does work for cube roots. The cube root of -8 is -2, because -2 times -2 is +4, +4 times -2 is -8. So you can take odd roots, so the third root, the fifth root, the seventh root, the ninth root of negative numbers. You just can't do an even root of a negative number. So that only works with even radical functions. How we find out what our domain restriction here is we have to do 3x minus 5 has to be greater than or equal to 0. It's totally fine to have 0 inside of a radical. The square root of 0 is 0. So then we just solve for x how we would normally solve for x. You add 5 to both sides, divide by 3. We flip the sign if we're dividing or multiplying by a negative number. Once you've gotten to this point, we then just put it into our domain set notation. X such that x is greater than or equal to 5/3. So normally when we're looking at domain and range for functions in an algebraic sense, all I'm asking for are restrictions. Would this equation have a restriction? And it only has restrictions when we're dealing with fraction functions as well as square root functions or fourth root functions or sixth root functions, even radical functions. So those are the two things you should be thinking of when we're asking you to find the domain with an algebraic representation. Okay, last part. I'm trying to go quickly. We need to practice solving for when f of x is equal to 0. This is a really fancy way of saying like, hey, let's set this equal to 0. So you replace f of x with 0. You say no longer f of x, just 0, not f of 0, because this means that we're setting y, or what we replaced with y, equal to 0. Whereas if we did f of 0, that would be setting x equal to 0. So it's two different ways of evaluating. This is setting the whole equation equal to 0, or another way setting y equals to 0. Hopefully we know how to solve this, so go ahead and do that on your own. We would have to add 16 to both sides, equals x squared, plus or minus 4 equals x. So hopefully that is what you got. You should have given me 2 answers. So let's go ahead and practice it again, and you can do this on your own. I want you to find when f of x equals 0. When f of x equals 0, that means we set the entire equation equal to 0. 0 equals x squared minus 5x plus 6. We know how to factor for this. 6 and negative 5 means that they both need to be negative and add to 5. So that's going to be negative 2 and negative 3. So x equals 2 and x equals 3. Okay, pretty straightforward things we've been doing from this whole time. The thing that I want you to take away from this is just how we're using the notation here. It's just introducing you to and getting you comfortable with new notation. We could also have notation that says this: f of x equals g of x. And you're told, hey, f of x equals this and g of x equals this. All you're doing is setting the two equations equal to each other. The reason why we do f and g, or you might see h or I or j or whatever, is that we're trying to differentiate between different functions. So we have multiple functions in a problem. We need to use a different variable in order to represent them, a different letter in order to represent them. So that's all. That's the reason why we have a g here and an f here, is because we're telling you, hey, these are two different equations. So all I need to do now is set them equal to each other. X squared plus 6x minus 24 equals 4x minus x squared. We know that this is a quadratic, which means we know that we need to set this equal to 0 first. Once I do that, I realize that I can divide everything by 2. From here, I would like for you to solve for it on your own. I know I'm looking for two numbers that multiply to negative 12 and subtract to positive 1. And that'll be x plus 4 and x minus 3 equals 0, which means we get x equals negative 4 and x equals 3. Last one. I would like for you to do this all on your own. Setting these guys equal to each other then results in the need to set it equal to 0. Checking to see if I can factor it. And I can. And then I can solve. X equals positive 3/2 and x equals, negative 1. Okay, so this is it for our equations about notes. Your first page was dealing with what is a function, why do we care about functions. We forgot to write down that the range is the set of all y values. So sorry. The definition of a function, that it's a relation that has one or more variable where each input has exactly one output. Then this idea of using f of x instead of y, how we evaluate what this means to say g of 3 is just replace all of your x values with 3, or g of t plus 1 means replace all of your x values like a puzzle, take it out and put in t plus 1. We then, on the following page, talked about what defines a function versus not a function. We talked about all these different ways that you can talk about it, and all these different ways that you can visually see this definition of each input having exactly one output. If you would like to try to make a function on your own, you are welcome to do so. We then talked about domain, how you find it with tables and lists versus how you find it with graphs. We talked about how you found your domain looking at algebraic expressions and equations. And then we talked about some notation that you know how to solve these guys mathematically. We're just talking about new notation that we need to get used to. So hopefully this all makes sense. I know this was a lot to go over. It's just these are all of the basic concepts that we need to know in order to move forward in this unit. So I'm introducing you to vocab and notation and ideas before we really delve into the main idea of this unit. Good job.